So here we have the graph of g of x. We want to sketch the graph of y equals g of 0.5 of x. So when we go from left to right here, the first number that we run into is the 0.5. We have to ask ourselves, is that going to affect the x or is that going to affect the y? It's going to affect the x because it's inside the function. And because it's a half, we're going to multiply our x by the reciprocal, which would be 2 over 1. So we're going to multiply our x by 2. Now on our original graph here, there are 4 key points. We're going to list all 4 of those. We have negative 3, 2, negative 1, 5, 3, 3, and 4, negative 2. To all of those points, you're going to multiply your x values by 2. And so we can list where all of our new points are going to be. So then when we go to label them, we'll have negative 6, 2, negative 2, 5, 6, 3, and 8, negative 2. Join those together, and we can see that our graph has been stretched horizontally by a factor of 2. Sometimes they ask you to describe in words what has happened. So for this one, we would say it has been stretched horizontally by a factor of 2. We use the word stretched whenever it's bigger than 1, and we use the word compressed whenever it gets squished. Again, we're asked for the domain. Domain and range. I'm going to use interval notation this time. I haven't done that for a bit. So our smallest x value is negative 3, and our biggest x value is 4. And our range, our smallest y value is negative 2. And our biggest y value is 5, I think. Yes. On our transformation, our smallest x value is now negative 6, and our largest x value is now 8. And for our range, it still goes from negative 2 to 5. And that should make sense, because if we think what changed, we took our x values and multiplied them by 2. So our y values don't change at all, and our x values have been multiplied by 2. Questions you can do for this one are 7, 9, and 10.